All right, this is AP BC Calculus. We're doing Unit 9, Section 2, which is the second derivatives of parametric equations. So basically, this is not a super intuitive formula. It's a single formula. It is one particular skill you're going to want to memorize because it's a very specific question. So let's go ahead and review what we know. So recall that in 9.1, the last fairly lengthy video, we learned that dy dx for a parametric curve is y prime of t over x prime of t, or dy dt over dx dt. The second derivative with respect to x is way less intuitive. We're going to walk through where the formula comes from, but it is definitely on the list of things you want to memorize because in a pinch, when you're stressed, it's very hard to intuit your way through this formula. Some of the stuff we're going to do, if you forget it, you can really logic through it easily using previous knowledge, like whether it's geometry or Pythagorean theorem or some algebra, but this is just not one that feels very intuitive. So if we want the second derivative with respect to x of this function, right? So d squared y dx squared, we're going to have to take the derivative of dy dx. But in order to do that, since we're not differentiating with respect to x because everything's in terms of t, we're going to have to make this in terms of t by multiplying by 1 over dt times 1 over dt. Again, the stuff in red, totally not intuitive. So that means that on the top, I have d over dt, and on the bottom, I have dx dt. So what's happening is we're going to differentiate the derivative we found, like the first derivative that we already have, with respect to t, and then we're going to divide that by dx dt. So that's our second derivative formula in parametric, and it's tricky, and it's not something that most of us are familiar with, so you just have to remember, I think really what it comes down to is a lot of us just go ahead and do the top part and forget that we're going to have to divide by dx dt, but this red is the logic of why it's divided by dx dt. So let's go ahead and find the second derivative, right? Okay, so the first thing we need to do is find the first derivative, right? So I can't find the second derivative until I find the first derivative. So dy dx, right, should be y prime of t over x prime of t. And I can find y prime to be a 3t squared. And I can find my x prime to just be a 2. Great. So I'd probably even write it as a 3 halves t squared. My d squared y dx squared is going to be the derivative with respect to t of this thing, of the 3 halves t squared, divided by dx dt, which we've already seen is a 2. So I'm going to get that this is a, when I drop the 2 down, I'm going to get that this is a 3t, and on the bottom I get a 2, and that's my answer, right? That's my second derivative with respect to x, right? Again, not super intuitive. I think that this is the part that a lot of us are going to forget, right? This is the part that we're going to forget. So a lot of us are going to forget, oh, hey, there's this piece of information here. That's the part that tends to be forgotten. I try to troubleshoot with you things that I think people are likely to forget, and that's one of them. So go ahead and try a P1. So again, first thing we need to do is find dy dx, which is going to be y prime of t over my x prime of t. Right, so that's going to be a 15t squared over a 6t, right? And I'd probably clean that up, right? I would suggest that you cancel a t so that you don't have to do the quotient rule, and I'd suggest that you cancel a 3 because it just makes your life a little bit easier, right? So I'd make this a 5 halves t essentially, right? That means that my d squared y dx squared is going to be the derivative with respect to t of the thing I just found, so the 5 halves t, right, divided by dx dt. So that's going to be a 5 halves on top of a 6t, right? So when I clean this up a little bit, I'm going to end up with a 5 over 12t. That's my second derivative with respect to x. All right, let's go ahead and do 2 more. So same concept. We're just going to practice this formula over and over. It's a very specific formula. So I need to find dy dx first, my bad, by doing y prime of t over x prime of t, right? So my y prime is going to be a 1 over t, and my x prime is going to be a 3t squared. So again, it really is worth simplifying this to make sure that you have the easiest version of this. Honestly, I'd probably write it as a 3t to the negative, a 1/3 t to the negative third, because I think that's easier. Notice the 3 did not flip up, and that's important, and that was almost a silly little mistake on my part, but I'd probably write it as that. So then to find my d squared y dx squared, right, I'm going to differentiate the derivative I just found, so I need to differentiate this thing, right, over dx dt. which I already did find to be a 3t squared, but I can find again. So when I differentiate the top, right, I'm going to get a negative 1t to the negative 4th, and on the bottom, I have a 3t squared. So that's a negative 1 over t to the 4th divided by a 3t squared. My final answer ends up being a negative 1 over a 3t to the 6th. Or an equivalent answer, like it would be fine to leave this as a negative 1/3 t to the negative 6th or something like that. All right, last one, and then this is a pretty quick video. All right, so same thing, right? We need to find our dy dx first, right? So that's my y prime of t over my x prime of t. So that's going to be a 2e to the 2t over a negative 3e to the negative 3t, right? And honestly, if I were you, I'd probably clean it up because they're both e bases, right? So you can make this a negative 2/3, and then it's an e to the 5t, and that makes life a lot easier. You don't have to, but I think it's a little bit easier. My second derivative, d squared y dx squared, is going to be the derivative with respect to t of the thing I just found, divided by dx dt, which we already know how to find because we already found it. It's right here. So I'm going to get that this is a negative 10/3 e to the 5t, right? Because it would be the derivative of e to the 5t, the negative 2/3 e to the 5t, which is negative 2/3 e to the 5t times the 5. And on the bottom, we already found dx dt. It's a negative 3e to the negative 3t, right? So if I want to clean this up a little bit, right, I end up with a 10/9 for the coefficient, right? And then this ends up being an e to the 8t. And if you're a little bit stuck on how I'm ending up with 10/9, just look at these numbers, right? If you do this, right, this is the same as a negative 10/3 times a negative 1 over 3, which is how I got the negative 10/9, right? So that's the work for how I got that. All right, and that is it for this video. So that's it for 9.2.